What if I told you there's a place in the universe where time itself breaks down, a place you can enter but never, ever leave? Today we're diving headfirst into one of the cosmos's greatest enigmas. We're going on a journey to answer the question, what would actually happen if you fell into a black hole? A black hole isn't a hole in the traditional sense. It's an incredibly dense concentration of matter packed into an impossibly small space. Its gravity is so powerful, so all-consuming that once you get too close, there's no turning back. Nothing, not even light, the fastest thing in the universe, can escape its pull. This is why black holes are, well, black. They don't reflect any light, making them invisible against the dark backdrop of space. We can only detect them by observing their effects on nearby stars and gas, which get whipped around in a gravitational dance of death. So let's imagine you're in a spaceship, drifting through the cosmos, and you've made a terrible navigational error. You're now on a collision course with a black hole. What's the first thing you'd notice? As you approach, the black hole would dominate your view, a perfect sphere of pure blackness, a void in the fabric of space-time. The stars around it would appear distorted, their light bent and twisted by the immense gravity, creating a mesmerizing but terrifying halo. But here's where things get really weird. Let's say your friend is watching you from a safe distance. From their perspective, as you get closer and closer to the edge of the black hole, something strange would happen to you. You'd appear to slow down. Your movements would become agonizingly sluggish, as if you were moving through cosmic molasses. The closer you get to the edge, the slower you'd appear, until you seem to freeze in time, hovering right at the boundary, red-shifted and fading away for all eternity. Your friend would never actually see you fall in. This boundary is called the event horizon. Think of it as the ultimate point of no return. It's not a physical surface you can touch, but an invisible line where the gravitational pull becomes so strong that the escape velocity is greater than the speed of light. Once you cross the event horizon, your fate is sealed. You are officially inside the black hole, and there is no way out. No matter how powerful your rockets are, you can't escape. Why? Because inside the event horizon, space itself is flowing inward faster than the speed of light, carrying you with it. All paths, all possible futures lead to one place, the center. Now, for you, the experience is completely different. You wouldn't feel yourself slowing down. As you cross the event horizon, you might not even notice anything dramatic at first. For a moment, it might feel like you've simply passed through an invisible curtain. The universe you left behind would now appear in a tiny, bright window above you, shrinking and blue-shifted as you fall deeper. But this brief moment of calm is the prelude to one of the most violent ends imaginable. As you continue your descent, the force of gravity would increase at an astonishing rate. And this is where things get messy. The gravitational pull wouldn't be uniform across your body. The part of your body closer to the center of the black hole, let's say your feet, would experience a much stronger pull than the part farther away, like your head. This difference in gravitational force is called a tidal force. This tidal force would begin to stretch you. Gently at first, but the stretching would become more and more intense. It's a process that astrophysicists have grimly, but accurately, named spaghettification. Your body would be pulled and elongated like a piece of spaghetti. You get thinner and thinner, longer and longer, until the forces become so extreme that they would overcome the molecular bonds holding you together. Your body would be torn apart, atom by atom, stretched into a thin stream of fundamental particles, spiraling down into the abyss. It's a gruesome end, but it's the inevitable consequence of meeting the raw, untamed power of a black hole's gravity. But what about time? We talked about how your friend sees you freeze at the edge, but what is time like for you on the inside? This is where Albert Einstein's theory of general relativity comes into play. It tells us that gravity warps not just space, but time as well. The stronger the gravity, the slower time passes. As you fall towards the center, time for you would be moving much, much slower relative to the outside universe. While only minutes or hours might pass for you on your journey to the center, millions or even billions of years could flash by for the rest of the cosmos. In a very real sense, falling into a black hole is like taking a one-way trip into the far, far future. You would witness the evolution of galaxies, the birth and death of stars, all in the blink of an eye. You'd become the ultimate time traveler, but it's a journey with no return ticket. So you've been spaghettified into a stream of atoms, and you've time traveled into the distant future. What happens next? Where does this stream of particles end up? All matter that falls into a black hole is crushed into an infinitely small, infinitely dense point at the very center. This point is known as the singularity. The singularity is where our understanding of the universe completely breaks down. All the known laws of physics, including Einstein's relativity and quantum mechanics, cease to make sense. At the singularity, space and time as we know them likely don't exist. It's a point of infinite density and zero volume, a concept that is mathematically mind-boggling and physically paradoxical. So what asterisk is asterisk the singularity? We honestly don't know. It's one of the biggest mysteries in science. Some theories propose that it's the absolute end. Everything that enters is simply crushed out of existence. But other, more speculative ideas suggest something even more profound. Could a singularity be a gateway? Some physicists theorize that black holes could be bridges to other parts of our universe, a cosmic shortcut known as a wormhole. However, even if this were true, the intense tidal forces would likely destroy anything trying to pass through. Another fascinating idea is that black holes could be the seeds of new universes. According to this theory, the matter and energy crushed at the singularity could rebound in a big bang of its own, creating a brand new baby universe, completely separate from our own. If this is true, our own universe might have been born from inside a black hole in a larger parent universe. It's a mind-bending concept that places black holes not as destroyers, but as creators. So, what really happens inside a black hole? The honest answer is that no one knows for sure. It is a place beyond our direct observation, a realm where our science reaches its limits. It's a cosmic question mark, a perfect, dark mystery that challenges the very foundations of our understanding of reality. Black holes remind us that the universe is far stranger, more complex, and more magnificent than we can possibly imagine. They are not just cosmic vacuum cleaners but laboratories of extreme physics, pushing the boundaries of space, time, and existence itself. The quest to understand them is a quest to understand the very fabric of our cosmos. Thank you so much for joining me on this journey into the unknown. If you enjoyed this cosmic adventure, don't forget to hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments what cosmic question you'd like me to explore next. Until then, stay curious.